The morning of November 12, 1942. Mid-Atlantic, 400 miles off the coast of Newfoundland. Captain Lieutenant Reinhard Hardigan surfaced his U-boat, U-123, in the pre-dawn darkness. Behind him, 3 merchant ships were sinking, their hulls torn open by torpedoes. He watched through his periscope as the third vessel, an American Liberty ship carrying tanks and ammunition to Britain, tilted bow first into the black water. 11 minutes from torpedo impact to complete submersion. His crew cheered below deck. Hardigan radioed Kriegsmarine headquarters with his confirmed kills, adding a personal note in his log. "The Americans build slowly. We sink quickly. Mathematics favors us." He was catastrophically wrong. While Hardigan wrote those words in his cramped submarine cabin, 6,000 miles away in Richmond, California, a woman named Beatrice Williams picked up her welding torch for the morning shift at Kaiser Shipyard No. 2. She was one of 18,000 workers who would, that very day, complete the assembly of an entire Liberty ship in 42 days. Not the hull, not the superstructure. The entire vessel, from keel to mast, ready to sail. By the time Hardigan returned to his base in occupied France 3 weeks later, Beatrice and her fellow workers had launched 2 more ships. For every vessel Hardigan sank that month, American shipyards produced 15. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. This is not a story about naval warfare. This is a story about arithmetic, about how American shipyards transformed the Battle of the Atlantic from a military contest into a mathematical certainty. About how men like Hardigan, skilled and brave and utterly committed to their mission, fought with perfect tactics against an enemy that had changed the rules of war itself. They were not defeated by superior strategy or better seamanship. They were defeated by the simple, brutal fact that no matter how many ships they sank, there would always be more. The year 1941 began with Britain on the edge of starvation. German U-boats prowled the Atlantic shipping lanes like wolves in a sheep meadow, and the statistics told a story of slow national suffocation. In January alone, German submarines sank 41 ships. In February, 39. March brought 41 more. The numbers climbed through spring and summer. British imports, which had averaged 55 million tons annually before the war, had collapsed to 30 million tons by mid-1941. Food rationing tightened week by week. By Churchill's own later admission, Britain had perhaps 3 months of food reserves left. The problem was not just the ships being sunk, it was the time required to replace them. Traditional shipbuilding was a craftsman's art, a slow and careful process that took 12 to 18 months per vessel. Each ship was essentially custom-built, its thousands of parts individually fitted by skilled workers who had learned their trade through years of apprenticeship. The British shipyards, already strained by bombing raids and labour shortages, could not possibly build ships faster than the U-boats could sink them. The Americans, despite their industrial capacity, faced the same fundamental constraint. Shipbuilding took time that Britain did not have. Admiral Karl Dönitz, commander of Germany's U-boat fleet, understood this arithmetic perfectly. He had calculated that if his submarines could sink 750,000 tons of Allied shipping each month, Britain would be forced to surrender within a year. The calculation was not mere speculation. It was based on meticulous analysis of Britain's import requirements, storage capacity, and shipbuilding rate. Dönitz had 130 operational U-boats in 1941, and he was getting more each month from German shipyards. His crews were well-trained, experienced, and motivated. His tactics, the Wolfpack system where multiple submarines coordinated attacks on convoys, had proven devastatingly effective. The mathematics, as Hardigan would later write in his log, favoured Germany. On December 7, 1941, while American attention focused on Pearl Harbor and the Pacific, President Roosevelt signed a contract that would ultimately matter more to the war's outcome than any single battle. The contract authorized the construction of 312 cargo ships to be built using methods that violated every traditional principle of shipbuilding. The vessels would not be crafted. They would be manufactured, assembled like automobiles on a production line, using standardized parts and unskilled labor. The man behind this radical proposal was Henry Kaiser, a California industrialist who had never built a ship in his life. Kaiser's background was in construction, not maritime engineering. He had made his fortune building dams and highways, projects that required moving enormous amounts of material quickly and efficiently. When the Maritime Commission approached him about building ships, Kaiser asked what seemed like a naive question. Why does it take so long? The answer he received, that shipbuilding was a specialized craft requiring years of training and custom fabrication for each vessel, struck him as absurd. A ship, Kaiser argued, was just a very large box that floated. Why couldn't it be built the way he built dams, using prefabricated sections assembled on-site by workers who knew how to follow blueprints? The maritime establishment considered Kaiser's ideas somewhere between ignorant and dangerous. Ships had been built essentially the same way for centuries. You laid a keel, erected ribs, attached plates with rivets, installed machinery and fittings, each step requiring skilled judgment and craftsmanship. Kaiser proposed to replace rivets with welding, craft with system, tradition with speed. His critics pointed out that he had no experience with the complex stresses a ship endured at sea, no understanding of maritime engineering, no respect for the proven methods that had built every naval vessel in history. They were correct about his inexperience. They were wrong about what mattered. The ship Kaiser proposed to build was based on a British design, a simple, sturdy tramp steamer that the British had been using successfully for years. It was not fast, achieving only 11 knots at maximum speed. It was not beautiful, its blunt bow and boxy superstructure earning it the nickname Ugly Duckling among sailors. It was not sophisticated, lacking the refinements and comforts of traditional cargo vessels, but it was buildable. More importantly, it was mass-producible. Kaiser called it the Liberty Ship, a name that would eventually apply to 2,700, 10 identical vessels, the largest fleet of ships ever, built to a single design. The first Liberty ship, the SS Patrick Henry, was launched on September 27, 1941, at the Bethlehem Fairfield Shipyard in Baltimore. It had taken 244 days to build, from keel laying to launch. This was actually faster than traditional methods, but still far too slow to replace the ships being sunk in the Atlantic. Kaiser promised he could do better, much better. His Richmond, California shipyard, which would become the largest shipbuilding facility in history, had not yet been built. When construction began in January 1942, Kaiser told his engineers he wanted the first ship completed in 90 days. They thought he was insane. The key to Kaiser's system was prefabrication. Instead of building the ship sequentially, from bottom to top, his workers built it simultaneously in hundreds of different locations. In vast assembly halls away from the shipways, workers welded together deck sections, bulkhead, panels, entire sections of hull plating. These prefabricated units, some weighing as much as 50 tons, were then transported to the shipway and lifted into place by enormous cranes. The ship was assembled like a massive three-dimensional puzzle, each piece manufactured to precise specifications so it would fit perfectly with the others. Welding replaced riveting as the primary method of joining metal plates. This change alone transformed shipbuilding. A riveted joint required a team of workers, one to heat the rivet, one to hold it in place, one to hammer it, one to support the work from the other side. The process was noisy, hot, and slow. A skilled riveting team could place about 600 rivets per day. A welded joint required one person with a welding torch, and that person could complete the equivalent of several thousand rivets in the same time. Welding was also stronger, creating a continuous joint rather than a series of individual attachment points. Kaiser's ships, contrary to his critics' predictions, were structurally superior to riveted vessels. But technology alone did not build ships. People did. And Kaiser needed tens of thousands of them, far more than the traditional shipbuilding workforce could supply. He recruited from everywhere: farmers, teachers, shop clerks, housewives. He hired women in unprecedented numbers, eventually employing more than 27% female workers at his Richmond yards. Many of these women had never held a paying job before the war. Some had never left their hometowns. They came to Richmond because Kaiser paid well, and because the work mattered in a way that transcended economics. Beatrice Williams, the welder who appeared at the beginning of this story, had been a schoolteacher in rural Kansas before the war. She had never seen the ocean, never held a welding torch, never worked in a factory. Kaiser's recruiters promised good wages, housing assistance, and childcare. Richmond had the first shipyard, childcare center in American history, open 24 hours a day to accommodate the round-the-clock shifts. Beatrice arrived in Richmond in April 1942 with her 2 children and $63 in savings. 6 weeks later, after intensive training, she was welding deck plates on Liberty ships, earning 95 cents an hour, more than triple her teacher's salary. The shipyard never stopped. 3 shifts, 8 hours each, workers arriving and departing in vast rivers of humanity. At peak production, Kaiser's 4 Richmond shipyards employed 90,000 people. The yards operated under floodlights at night, the arc welders' blue-white flashes visible for miles, a constellation of industrial fire that turned the night into perpetual artificial day. The noise was immense, continuous, almost unbearable. Cranes grinding, hammers pounding, welding torches hissing, truck engines roaring, steam whistles screaming. Workers learned to communicate through hand signals and shouting directly into each other's ears. Many suffered permanent hearing damage. Some were injured or killed when massive prefabricated sections broke loose or when mistakes with the enormous electrical systems caused fires or electrocutions. The work was dangerous, exhausting, and absolutely essential. By July 1942, Kaiser had reduced Liberty ship construction time to 105 days. By September, 75 days. The Richmond yards were launching a new ship every week, then every 5 days. Then nearly every day. Other shipyards across America, inspired by Kaiser's success and under enormous pressure from the Maritime Commission, adopted similar methods. The American shipbuilding industry became a vast, synchronized machine, producing Liberty ships in quantities that seemed impossible even to the Americans building them. Meanwhile, in the Atlantic, German U-boats continued their campaign of destruction. 1942 was their most successful year. In May alone, U-boats sank 125 Allied ships, totaling over 600,000 tons. Hardigan, the commander from our opening scene, became one of Germany's most decorated U-boat aces, sinking over 200,000 tons of Allied shipping in multiple patrols. The U-boat crews were professional, skilled, and brave. They hunted in coordinated wolf packs, sharing intelligence and concentrating force against convoys. Their tactics were sound. Their equipment, particularly after the introduction of acoustic torpedoes in late 1942, was excellent. They were winning the Battle of the Atlantic by every measure that had mattered in every previous naval war. Except one. They could not sink ships faster than America could build them. The mathematics that Dönitz had calculated so carefully in 1941 began to shift. For every ship sunk in the first half of 1942, American and British yards launched 1.1 replacement ships. By the second half of 1942, the ratio had improved to 1.5. By early 1943, for every ship the U-boats managed to sink, the Allies launched 3 replacements, and the curve was still climbing. On November 12, 1942, exactly 1 year to the day after Hardigan had sunk 3 ships and written that the mathematics favoured Germany, Kaiser's Richmond Yard No. 2 launched the SS Robert E. Peary. The ship had been built in 4 days, 15 hours, and 30 minutes, from the moment the keel was laid to the moment it slid into the water. Peary was fully functional, complete with engines, armament, navigation equipment, cargo holds, crew quarters, every system tested and operational. It could have sailed into combat that afternoon. 4 days. The previous record for Liberty ship construction, set by Kaiser's own yards just weeks before, had been 7 days. Kaiser's workers had cut that record nearly in half. The Robert E. Peary would remain the fastest ship ever built for the rest of the war, but the average construction time across all American shipyards continued to drop. By mid-1943, the average Liberty ship took 42 days to build. Some yards achieved 30 days. The American shipbuilding industry had transformed what should have been impossible into routine. German naval intelligence tracked these numbers with growing alarm. Their reports to Dönitz documented American shipbuilding capacity in precise, devastating detail. In 1942 alone, American yards launched 747 merchant ships, totaling over 8 million deadweight tons. This was more tonnage than Germany's entire merchant marine at the start of the war, and 1943's numbers would be even higher. Dönitz faced a problem that no amount of tactical skill could solve. His U-boats were achieving unprecedented success rates. Individual commanders were sinking more tonnage per patrol than at any time in the war. The Wolfpack tactics were working exactly as designed, but the overall strategic situation was deteriorating because the fundamental arithmetic had changed. Sinking ships no longer mattered if those ships were replaced before their loss could have strategic effect. To understand what the Germans were facing, you need to understand what a Liberty ship actually was. Not the mythology, not the propaganda, but the precise specifications of the vessel that redefined industrial warfare. The EC-2SC-1 design, the official designation for what became the Liberty ship, measured 441 feet, 6 inches in length overall, beam of 56 feet, 10 3/4 inches, depth of 37 feet, 4 inches from the main deck to the keel, displacement of 14,245 long tons when fully loaded. These were not large ships by military standards. A battleship displaced 4 times as much. An aircraft, carrier, 6 times. But size was never the point. The hull was constructed from 2,500 individual steel plates, welded together in a continuous structure. The main deck consisted of 5 separate holds, totaling 462,000 cubic feet of cargo space. Each hold could be loaded independently through booms and winches operated by the ship's own steam-powered cargo handling equipment. The vessel could carry 10,400 tons of cargo in its holds, plus additional deck cargo if necessary. That tonnage translated to 300 Sherman tanks, or 2,800 jeeps, or 4,400 tons of ammunition, or enough food to feed an army division for 2 months. The power plant was a 2,500 horsepower triple expansion reciprocating steam engine, the same basic design that had powered ships since the 19th century. Kaiser chose this engine not because it was modern or efficient, but because it was simple and could be manufactured quickly by companies that had never built marine engines before. The engine turned a single propeller at 76 revolutions per minute, pushing the ship through the water at 11 knots maximum speed, though most Liberty ships cruised at 9 knots to conserve fuel. This was slow by any standard. A destroyer could make 35 knots. Even traditional cargo vessels managed 15. But speed was not the priority. Reliability was. The fuel capacity was 66,900 gallons of bunker oil, stored in tanks along the ship's bottom. This gave the Liberty ship a range of approximately 20,000 nautical miles at cruising speed, enough to cross the Atlantic 4 times without refueling. The ships carried 250 tons of fresh water in dedicated tanks, with condensers that could produce an additional 3,000 gallons per day from seawater. The crew quarters, designed for a complement of 44 men plus 12 naval-armed guard gunners, were cramped and basic. Officers had individual cabins measuring 8 feet by 6 feet. Crew members slept in bunks, stacked 3 high in compartments that housed 12 men each. Defensive armament varied depending on when the ship was built and where it was deployed. The standard configuration included one 3-inch, 50 caliber gun mounted on the stern, operated by the Naval Armed Guard Detachment. 8 20mm Oerlikon anti-aircraft guns were distributed around the ship's superstructure. Some later vessels received 5-inch guns or additional machine guns. These weapons were not sufficient to fight off a determined air attack or surface raider. They were meant to make attacking the ship expensive enough that raiders might choose easier targets. The bridge, navigation equipment, and radio room occupied the midship house, a boxy superstructure that rose 3 decks above the main hull. The wheelhouse contained a magnetic compass, gyro compass, engine, order telegraph, rudder angle indicator, and basic navigation plotting table. The radio room had standard marine communication equipment, capable of transmitting distress signals and receiving convoy instructions. Navigation was done using sextants, chronometers, and paper charts. Radar, when installed, was primitive by later standards, but revolutionary for merchant vessels that had never had any electronic detection equipment before. The construction process that produced these ships was as precisely specified as the ships themselves. Kaiser's prefabrication system divided each Liberty ship into 498 separate assemblies. These ranged from small units like ventilator cowlings that weighed a few hundred pounds to massive double-bottom sections that weighed 45 tons. Each assembly was manufactured in dedicated work areas away from the shipways, then transported to the construction site when needed. The hull itself consisted of 47 prefabricated sections. The keel was laid in 3 pieces, each 90 feet long, positioned and welded together on the building ways. The double bottom, the space between the outer hull plates and the inner bottom that provided both structural strength and protection against torpedo damage, was assembled from 16 separate sections. The side shell came in 18 pieces, the deck in 6. The bulkheads, the vertical walls that divided the ship into compartments, were built as complete units and lowered into place by the yard's largest cranes. Welding these sections together required precise coordination. Kaiser's yards employed what they called the block erection system. The keel sections went down first, positioned on the building ways using surveying equipment accurate to 1/16 of an inch. The double-bottom sections were then lowered into place and welded to the keel. The side shell sections came next, positioned using temporary supports and jigs that ensured proper alignment before the final welds were made. The deck sections were the last major hull components to be installed, essentially forming the roof of the massive steel box. Each welded joint required specific procedures. The welders worked in teams, usually one welder with 2 helpers who cleaned the metal surfaces, positioned backing bars, and inspected completed welds. The welding rods, thousands of them per ship, were stored in heated ovens to keep them dry. Damp welding rods produced weak, porous welds that could crack under stress. The welders themselves worked in conditions that ranged from uncomfortable to actively dangerous. Inside the double bottom or in confined spaces between bulkheads, temperatures could exceed 120 degrees. The welding arc produced intense ultraviolet light that could cause severe eye damage without proper protection. The confined spaces filled with welding fumes that could overcome workers who didn't maintain proper ventilation. Quality control was constant and rigorous. Inspectors examined every major weld using both visual inspection and X-ray equipment. Suspicious welds were ground out and redone. Structural tests were performed on completed sections before they were installed. The pressure hull, the portion of the ship below the waterline, was inspected with particular care because any failure there could sink the vessel. Despite the speed of construction, the Liberty ships had excellent structural integrity. Fewer than 2% experienced major structural failures during the war, a lower rate than traditionally built ships. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The machinery installation followed its own systematic process. The main engine, built in sections by companies like Joshua Hendy Iron Works in California, arrived at the shipyard as approximately 40 separate components. The largest was the engine bedplate, a massive cast steel foundation that weighed 20 tons. This was lowered into the engine room and bolted directly to the ship's structure. The engine cylinders, each weighing several tons, were then positioned and secured to the bedplate. The crankshaft, propeller shaft, and reduction gearing were installed as a synchronized unit, requiring precision alignment to prevent bearing failures. The boilers, 2 per ship, were installed before the deck was completed, lowered through openings that would later be sealed. The electrical system was surprisingly complex for such a basic ship. More than 50 miles of electrical cable ran through the vessel, connecting lighting, communication equipment, cargo handling machinery, and auxiliary systems. The main switchboard, located in the engine room, controlled the distribution of electrical power from 2 diesel generators. Emergency lighting systems operated from battery banks that could provide illumination for 12 hours if the main generators failed. The radio equipment, while basic, required careful installation and calibration to meet naval communication standards. By mid-1943, these specifications and construction methods had become standardized across 15 major American shipyards. Richmond, Portland, Houston, Savannah, Baltimore, and other cities had transformed themselves into vast ship factories. The process was so refined that workers at different yards could identify which yard had built a particular ship just by examining minor details of the construction. Richmond ships had slightly different ventilator designs than Baltimore ships. Portland used a particular pattern of deck plating that differed from Houston's standard. These variations were cosmetic, but they reflected the pride different yards took in their work. The German naval intelligence officers who compiled detailed reports on Liberty ship construction understood what they were observing. Their documents, preserved in various archives, show careful analysis of American shipbuilding capacity, production rates, and technical specifications. They calculated that American yards were producing merchant shipping at a rate 6 times faster than German U-boats could sink it. They estimated, correctly, that by the end of 1943, America would have built more than 2,000 Liberty ships. They recognized that this industrial output represented a fundamental shift in the nature of naval warfare. What German intelligence could document and what U-boat commanders experienced in the Atlantic were not the same thing. Statistics were abstract, sinking ships was concrete, and the men who spent months at a time submerged in cramped, diesel-stinking submarines hunting convoys through the North Atlantic did not think in terms of aggregate tonnage or production statistics. They thought about the torpedo that hit, the ship that exploded, the crew they could see abandoning their sinking vessel. Each success felt like victory. The larger pattern was invisible from the conning tower of a submarine. Korvettenkapitän Peter Kramer commanded U-333, one of the newer Type 7C submarines that represented Germany's primary Atlantic weapon. On March 17, 1943, while patrolling south of Greenland, Kramer's lookout spotted a convoy designated SC-122, 38 merchant ships, 9 escorts. Kramer radioed the sighting to U-boat headquarters, and within 18 hours, 20 U-boats had converged on the convoy. The battle lasted 5 days. Kramer and his fellow commanders used classic wolfpack tactics: shadow the convoy during daylight, attack on the surface at night when the submarines could use their superior surface speed to maneuver into position. They penetrated the escort screen repeatedly. Kramer personally sank 3 ships, including 2 Liberty ships loaded with tanks and aircraft parts. Other U-boats sank 9 more vessels. It was a significant tactical victory, the kind that would have crippled Britain's strategic position in 1941. Kramer returned to base in occupied France on March 26 and filed his action report with satisfaction. 12 ships sunk, thousands of tons of critical war material sent to the bottom. The mathematics seemed clear. But while Kramer had been at sea hunting SC-122, American shipyards had launched 63 Liberty ships, not 63 ships total. 63 Liberty ships alone, not counting other types of cargo vessels, tankers, or military craft. The realization came gradually, ship by ship, patrol by patrol. U-boat commanders would return from missions where they had achieved everything their training and tactics had prepared them to do, only to be briefed on convoy sightings that included more ships than had existed in previous months. The intelligence reports showed American construction numbers that seemed impossible: 3 ships per day, 5 ships per day. Numbers that should have represented weekly or monthly totals, not daily production. Captain Lieutenant Herbert Werner, another experienced U-boat commander, wrote in his memoir about the moment the situation became clear to him. It was June 1943, during a patrol that had seen his U-boat dodge destroyers, survive depth charge attacks, and successfully torpedo a freighter. They surfaced in the pre-dawn darkness to recharge batteries and found themselves near a convoy route. Through his binoculars, Werner counted ships. More than 40 merchant vessels, most of them Liberty ships, their distinctive silhouettes unmistakable even in poor visibility. Werner's radio operator intercepted coded messages from other U-boats in the area. 5 submarines were converging on the convoy. Between them, they might sink 6 or 7 ships if conditions were perfect, if the escorts made mistakes, if luck favored the attackers. Werner did the arithmetic in his head. 6 ships, sunk from a convoy of 40. New ships launched daily. He later wrote, "I understood in that moment that we were not fighting a war. We were fighting arithmetic, and arithmetic does not care about courage." The psychological impact of this realization varied among U-boat crews. Some maintained their fighting spirit through sheer determination, focusing on each individual mission rather than the larger strategic picture. Others grew cynical, continuing to fight because orders were orders and desertion meant execution, but no longer believing in victory. A few, like Kremer, maintained optimism almost until the end, convinced that new technology or changed tactics might shift the balance. But the balance was shifting, and not in Germany's favor. The introduction of improved anti-submarine weapons made 1943 increasingly deadly for U-boats. Better radar allowed Allied escorts to detect surfaced submarines at night. Improved sonar made underwater detection more reliable. Escort carriers brought air cover to mid-Atlantic convoys that had previously operated beyond land-based aircraft range. The Ley light, a powerful searchlight carried by patrol aircraft, turned night surface attacks from relatively safe to potentially suicidal. More importantly, there were simply more escorts. American shipyards that built Liberty ships also built destroyer escorts, small but capable anti-submarine vessels designed specifically for convoy protection. These destroyer escorts, like the Liberty ships, were mass-produced using prefabrication and welding. By mid-1943, convoys that had previously sailed with 2 or 3 escorts now had 8 or 10. The tactics that had worked in 1942, penetrating thin escort screens and attacking the vulnerable merchant ships, became progressively more difficult and dangerous. May 1943 marked the turning point. That month, German U-boats sank 34 Allied ships. Simultaneously, 43 U-boats were destroyed by Allied forces, most in the Atlantic. For the first time in the war, U-boat losses exceeded ship sinkings. Dönitz, facing losses he could not sustain, withdrew his submarines from the North Atlantic convoy routes in late May, conceding defeat in the campaign that had nearly starved Britain into surrender. The withdrawal was not permanent. U-boats would return to the Atlantic with improved technology. Snorkels that allowed submarines to run diesel engines while submerged, acoustic torpedoes that homed on propeller noise, better radar detectors. But they never regained the advantage. The mathematics that Hardigan had thought favoured Germany in November 1942 had reversed completely. By the end of 1943, Allied merchant tonnage had increased despite all U-boat successes. The ships kept coming, an endless steel river flowing from American ports into the Atlantic. The Liberty ships themselves, the physical vessels that represented this industrial revolution, were not invulnerable. They sank regularly and in large numbers. Of the 2,710 Liberty ships built during the war, approximately 200 were lost to enemy action. Torpedoes, mines, aircraft bombs, and surface raiders destroyed ships that had taken weeks to build and carried crews who had days or hours to abandon ship when disaster struck. The SS Richard Hovey sank in April 1944 after hitting a mine off the Normandy coast during the D-Day preparations. The ship broke in half and went down in 7 minutes. 15 crewmen died, trapped below decks when the mine detonated. The SS Paul Hamilton was hit by German aircraft torpedoes in the Mediterranean in April 1944. The ship was carrying depth charges and ammunition. The torpedo detonation triggered a catastrophic explosion that vaporized the vessel. None of the 504 men aboard survived. The SS John Harvey was sunk in an air raid on Bari Harbour in December 1943. The ship carried mustard gas shells intended for potential retaliation if Germany used chemical weapons. When the John Harvey exploded, the gas spread through the harbour, killing more than 600 military personnel and civilians. These disasters were tragic and deadly, but they did not change the strategic calculus. The Richard Hovey sank on April 28, 1944. On that same day, American shipyards launched 7 Liberty ships to replace it. The Paul Hamilton went down on April 20, 1944. 6 Liberty ships were launched that day. The John Harvey was destroyed on December 2, 1943. 8 Liberty ships were launched on December 2. The industrial system that had produced these ships continued without pause, absorbing losses that would have crippled traditional shipbuilding nations. The crews who sailed aboard Liberty ships understood their vessels' limitations intimately. The ships were slow, making them vulnerable to submarines that could easily outrun them on the surface. They were minimally armed, unable to defend effectively against determined air or surface attack. Their welded hulls, while generally strong, occasionally developed cracks in cold water, and several ships broke apart in severe storms. The accommodations were Spartan, the work difficult, the voyages long and often terrifying. Captain Raymond Moore commanded the SS Stephen Hopkins, one of the few Liberty ships to engage a surface raider in direct combat. On September 27, 1942, while sailing independently in the South Atlantic, the Stephen Hopkins encountered the German commerce raider Steer and her supply ship. The German vessels, armed with 6-inch guns and automatic cannons, far outgunned the Liberty ship's single 3-inch gun and modest machine guns. Moore ordered his crew to battle stations. The Naval Armed Guard commander, Ensign Kenneth Willett, trained the stern gun on the Steer and opened fire. The engagement was suicidally brave. The German ships, faster and far more heavily armed, poured fire into the Liberty ship. Shells tore through the Stephen Hopkins's thin hull plating. The bridge was destroyed. The engine room flooded. Fire broke out in multiple locations, but Willett and his gun crew kept firing. They hit the Steer repeatedly, damaging the raider's engine room and starting fires that the German crew could not control. After 30 minutes of combat, both ships were sinking. The Stephen Hopkins went down first, taking Captain Moore and 19 other crew members with it. The Steer burned for 4 hours before her own crew abandoned ship and scuttled the raider. It was the only time during the war that a Liberty ship sank an enemy warship in a guns-only surface engagement. The survivors from the Stephen Hopkins, including Ensign Willett, spent 31 days in open lifeboats before reaching the Brazilian coast. Willett received the Navy Cross, the Naval Armed Guard crew received commendations, and the Stephen Hopkins became part of Liberty ship legend. But within 3 weeks of her loss, another Stephen Hopkins could have been built. The name was not reused, but the ship's material equivalent, 10,000 tons of cargo capacity, was already sailing from American ports. This was the heart of the strategic transformation the Liberty ships represented. Individual ships could be lost, individual crews could die, individual cargoes could be destroyed. None of it mattered to the overall equation if the loss rate remained below the replacement rate. Traditional naval warfare had operated on the assumption that ships were precious, limited resources that required years to replace. The Liberty ship system made ships expendable, which paradoxically made them strategically invincible. The cargoes the Liberty ships carried rewrote the global balance of power. In 1942 and 1943, while the Battle of the Atlantic still raged, Liberty ships delivered the equipment that allowed Britain to survive and begin preparing for offensive operations. They carried food, wheat from Kansas, beef from Texas, canned goods from California. They carried raw materials, steel plate, copper wire, rubber, timber, coal, petroleum products. They carried manufactured goods, trucks, jeeps, locomotives, rails, construction equipment, medical supplies, uniforms, boots, tents, radios. Most importantly, they carried weapons. Tanks by the thousand, artillery pieces by the hundreds, aircraft by the tens of thousands. Small arms ammunition measured in billions of rounds, artillery shells, bombs, depth charges, torpedoes, mines. The Liberty ships turned America's industrial capacity into deployed military power, crossing the Atlantic despite submarine threat and delivering the material that made Allied victory possible. The Soviet Union received a substantial portion of Liberty, ship cargoes through the dangerous Murmansk convoy route. These Arctic convoys faced not only U-boats, but also surface raiders and aircraft operating from Norwegian bases. The PQ-17 convoy in July 1942 suffered catastrophic losses when poor tactical decisions left the merchant ships undefended. 24 of 35 ships sunk, including 8 Liberty ships. But the convoys continued. PQ-18 in September delivered 27 of 40 ships despite heavy attacks. Subsequent convoys improved their survival rates as escorts became more numerous and better equipped. The equipment delivered to the Soviet Union, much of it carried in Liberty ships, sustained the Red Army through the critical battles of Stalingrad and Kursk. 427,000 trucks, more than the entire German army possessed, 13,000 tanks, 11,000 aircraft. These numbers represented not just equipment but operational capability. The Red Army's offensives of 1944 and 1945 depended on logistics, and Liberty ship cargoes provided the trucks, fuel, and supplies that made those offensives possible. In the Pacific theater, Liberty ships served different but equally critical roles. The island-hopping campaign required enormous logistical support, moving supplies across thousands of miles of ocean to forward bases that had minimal infrastructure. Liberty ships hauled aviation fuel for B-29s, bombing Japan, food for garrison forces, construction materials for airfields, ammunition for the advancing forces. The vessels were not designed for Pacific operations, their slow speed and limited maneuverability making them vulnerable to submarine and air attack, but they went anyway because the cargo had to move. The SS Jean Nicolet, operating in the Pacific, survived being torpedoed twice. The first torpedo, from a Japanese submarine in November 1944, blew a hole in her hull but failed to detonate, the cargo of ammunition. The crew made temporary repairs and reached port. After repairs and reloading, the Jean Nicolet returned to service. In March 1945, another Japanese torpedo hit her stern, destroying the steering gear and jamming the rudder. The crew rigged emergency steering and again reached port. The ship survived the war and remained in service until 1963, a testament to both Liberty ship construction quality and the luck that some vessels enjoyed. Not all were so fortunate. The SS John Burke, loaded with ammunition and phosphorus bombs, was hit by a Japanese kamikaze in December 1944 while anchored off later. The resulting explosion was so massive that wreckage rained down over a mile radius. The ship and all 71 crew members were obliterated instantly. The explosion was visible from 20 miles away and registered on seismographs as a small earthquake. But within a month, the cargo the John Burke had carried was replaced by other ships, and the invasion of Luzon proceeded on schedule. By late 1944, Liberty ship production had become routine enough that the drama had left the process. The ships that had seemed miraculous in 1942 were now simply normal. Shipyards met quotas without celebration. New ships slid down the ways with minimal ceremony. The industrial machine that had required frantic improvisation and innovation to create now operated with the smooth efficiency of mature technology. The final Liberty ship, the SS Albert M. Bow, was launched on October 30, 1945, 5 months after Germany's surrender and 2 months after Japan's. Total production, 2,710 ships. Total tonnage, approximately 29 million deadweight tons. This exceeded the combined merchant tonnage of Germany, Italy, and Japan at the war's start. It exceeded Britain's entire merchant fleet. It represented more shipping capacity than had existed, in the entire world before the war. The cost, in both money and materials, was staggering. The average Liberty ship cost $1.7 million to build, approximately $30 million in modern equivalent. Multiply that by 2,710 ships, and the total approaches $81 billion current dollars just for the Liberty ships alone, not counting the yards, equipment, training, and infrastructure required to build them. The steel consumption was equally enormous, 10,000 tons per ship, 27 million tons total, more steel than had been produced globally in any year before 1920. Yet this cost paled compared to the strategic value. Without the Liberty ships, Britain would likely have surrendered in early 1942. Without the cargoes they carried, the Soviet Union might have collapsed. Without the logistics capability they provided, the D-Day invasion would have been impossible. Without the supplies they delivered across the Pacific, the island campaign could not have succeeded. The Liberty ships did not win the war alone, but they made winning possible. For the men who had tried to sink them, the Liberty ships remained a source of both frustration and grudging respect. Hardigan, the commander from our opening scene, who had believed the mathematics favoured Germany, survived the war and later wrote extensively about his experiences. In his post-war memoirs, he acknowledged what German intelligence had understood, but what he had not wanted to believe during the war: that American industrial capacity had transformed naval warfare in ways that made traditional tactics irrelevant. "We were excellent hunters," Hardigan wrote. "Our tactics were sound. Our crews were brave. Our equipment was adequate to the task. But we were hunting animals that reproduced faster than we could kill them." It was a war of production, and we could not win a war of production against America. Kremer, who had successfully attacked convoy SC-122 and sunk multiple Liberty ships, reached a similar conclusion. In his memoir, U-Boat Commander, published in 1984, he described the psychological shift that occurred among U-boat crews in mid-1943. "We stopped counting ships sunk and started counting how many patrols we could survive. The ships meant nothing. They were replaced instantly. We could sink 10 ships, and the convoy still had 40. We could sink 20 and more arrived. The mathematics had become impossible." Werner, whose binoculars and arithmetic moment was described earlier, survived the war and emigrated to America, where he worked in the shipping industry. He spent decades studying the Liberty ship program and eventually wrote a detailed analysis of how the German Navy had fundamentally misunderstood what they were facing. "We prepared to fight the British Empire," Werner wrote. "We trained to combat their naval traditions, their seamanship, their tactical expertise. We did not prepare to fight an industrial system. We could not sink manufacturing capacity." Dönitz himself, in his post-war interrogations and later writings, never fully accepted that the U-boat campaign had been strategically futile. He continued to argue that with more submarines, better technology, or different tactical approaches, the outcome might have changed. But his own operational logs and reports show the moment when the arithmetic became undeniable. In July 1943, Dönitz wrote to Hitler requesting 400 additional U-boats to resume offensive operations in the Atlantic. The request was denied, not because Germany lacked the industrial capacity to build submarines, but because the steel and labor required to build 400 U-boats would reduce tank and aircraft production at a time when Germany faced invasion from the east and bombing from the west. Germany could build U-boats or build tanks. They could not build both in the quantities needed. America built Liberty ships, tanks, aircraft, and every other weapon system simultaneously, in quantities that exceeded Germany's total production across all categories. This was the core reality that sank the U-boat campaign more thoroughly than any tactical defeat. The irony that German commanders eventually recognized was that their most successful period, the first half of 1942, when U-boats sank record tonnage, had mattered least to the war's outcome. The ships they sank in those months had been replaced by midsummer. The convoys they scattered had reformed. The supplies they destroyed had been reloaded on new vessels. Their tactical victories had achieved nothing strategically, because the American industrial system had already shifted the foundation of maritime warfare. Some U-boat veterans struggled with this realization for decades. They had been told they were fighting for survival, that sinking Allied shipping was Germany's path to victory. They had risked their lives, watched friends die, endured conditions that would be considered torture in peacetime, all in pursuit of a mission that, in retrospect, had been hopeless from the moment the first Liberty ship launched. The psychological burden of that realization varied. Some accepted it as the fortune of war, others carried bitterness into old age. But among those who studied the war professionally, particularly military historians and strategists, the Liberty ship program became recognized as one of the most consequential industrial achievements of the 20th century. Not because the ships themselves were remarkable, they were deliberately unremarkable, but because they represented a new paradigm of warfare. The side that could produce weapons faster than they could be destroyed would eventually win, regardless of tactical skill or strategic brilliance. The Liberty ship's legacy extended far beyond World War II. The mass production techniques Kaiser pioneered became standard in post-war shipbuilding. The welding methods replaced riveting across the global industry. The prefabrication concepts influenced construction methods in buildings, bridges, and industrial facilities. The idea that complex systems could be manufactured by semi-skilled workers following standardized procedures transformed American industry. Many Liberty ships continued operating after the war ended. Some were converted to civilian cargo service and operated profitably into the 1960s. Others were mothballed and kept in reserve fleets, ready for reactivation if needed. A few saw combat again during the Korean War, carrying supplies to UN forces. The SS John W. Brown and the SS Jeremiah O'Brien remain operational museum ships, maintained by volunteer organizations and occasionally taken to sea for commemorative voyages. The workers who built the ships, people like Beatrice Williams, the Kansas schoolteacher turned welder, scattered after the war ended. Many women returned to domestic life, their wartime employment considered temporary necessity rather than permanent social change. The shipyards themselves declined. Richmond's vast Kaiser yards, which had employed 90,000 workers at peak production, closed in 1945. The buildings were dismantled, the shipways removed, the land repurposed. The industrial constellation that had lit the night sky with welding torches dimmed and went dark. But the impact remained. The Liberty ship program proved that industrial capacity, properly organized and ruthlessly focused, could override traditional military advantages. It demonstrated that mass production, which had transformed consumer goods in the 20s and 30s, could transform weapons of war with equal effect. It showed that the nation which could build fastest, not the nation which could fight best, would prevail in industrial age warfare. For Hardigan, the U-boat ace who had written in November 1942 that the mathematics favored Germany, the post-war years brought a long life and eventual recognition of his miscalculation. He died in 2006 at age 93, having outlived most of his U-boat comrades and most of the Liberty ships they had tried to sink. In one of his final interviews, asked what he would have done differently if he had understood American production capacity in 1942, Hardigan laughed quietly and said, "I would have surrendered immediately. You cannot fight a factory." The Battle of the Atlantic, which had seemed in 1941 to be a contest between German submarines and British convoys, had transformed into something entirely different. It became a race between torpedoes and shipyards, between tactical excellence and industrial output, between the limited resources of occupied Europe and the vast capacity of American industry. The outcome, once American production reached full scale, was never in doubt. The mathematics had shifted, and mathematics does not negotiate. The Liberty ship, that ugly, slow, basic cargo vessel that violated every principle of traditional shipbuilding, had won a naval war by making ships expendable. In doing so, it changed the fundamental nature of maritime conflict and demonstrated a truth that would define the remainder of the 20th century. In modern war, the nation that can produce most wins. No amount of skill, courage, or tactical brilliance can overcome an opponent who can replace losses faster than you can inflict them. 4 days to build a ship. That was the measure of American industrial power in World War II. 4 days from keel to launch, from blueprint to blue water. Against that measure, against that relentless production, the best submarines and the bravest crews in the world could achieve nothing more than temporary, local, ultimately meaningless victories. They sank ships. America built more. They refined tactics. America built more. They introduced new weapons. America built more. The mathematics, which Hardigan had thought favored Germany, had proven catastrophically wrong, not because his calculations were incorrect given the information available in 1941, but because the nature of the equation changed completely when American industry shifted to war production. The Liberty ships represented that change, made it concrete, turned abstract industrial capacity into steel vessels that crossed the Atlantic despite all opposition. In the end, the Battle of the Atlantic was not decided by brave men in submarines or sailors manning convoy escorts. It was decided by women with welding torches in Richmond, California, by workers who had never seen the ocean-building ships in Portland, Oregon, by engineers who turned shipbuilding into manufacturing in Houston, Texas, by a nation that understood, perhaps better than any nation before it, that modern war would be won not on battlefields, but in factories. The Liberty ships sailed in their thousands, carrying the weight of nations, delivering the material that made victory possible. They were not graceful. They were not fast. They were not sophisticated. They were simply enough. And in war, enough, delivered reliably and in overwhelming quantity, beats perfection delivered slowly and in limited numbers. 4 days to build a ship. That was how America won the Battle of the Atlantic, not with better strategy, not with superior tactics, but with arithmetic. Brutal, simple, undeniable arithmetic. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.